Lesson 2, Part 2. So we continue to look at how computers understand human language. And this is Lesson 2, Part 2. So binary language. In Lesson 2, Part 1, we made mention of binary system. And then we said that binary system is a number system which is made up of only two values, and that is 0 and 1. And then we also established that the computer actually understands or deals with zeros and ones. That is the binary system. So the zeros and ones that the computer understands is what is known as what? Binary language. These zeros and ones understood by the computer system is what is called binary language. Binary language is also the same as machine language. So machine language is also zeros and ones. So machine language is the language that is actually understood by the computer system. So moving forward, we said that machine language is just a series of zeros and ones. So series of zeros and ones, that is zeros and ones that are actually combined. So the machine language is just a series of zeros and ones. As we humans, we have our native language that we speak. The machine language is also the native language of the computer. So the language that the computer is actually born with is the machine language. That is a language of zeros and ones. So we can say that the native language of the computer is what? Is machine language. That is zeros and ones. So the computer actually throughout its life is going to deal with what? With zeros and ones, and that is its language. It actually understands and then it speaks zeros and ones. So what does it mean? If a programmer would want to write or communicate his ideas or write the set of instructions that the computer should follow to perform a task, then the programmer should be able to speak the native language of the computer, that is zeros and ones. Programmers are supposed to program using zeros and ones. So programmers should have been writing the set of instructions that the computer follows to perform a task using machine language, that is zeros and ones. And the question is this possible that programmers can actually code or write a set of instructions using zeros and ones? The answer is no. Humans cannot write the set of instructions using machine language. Why? Because humans, we don't deal with zeros and ones. We deal with what? With characters, symbols, and then alphabets. So because we humans or programmers cannot deal with zeros and ones, they introduce what is called assembly language. So, and because it is practically impossible for humans, that programmers, to write codes in machine language, assembly language was introduced. So assembly language used what is called symbolic codes, or we will say mnemonics, to represent some instructions that the computer actually performs. They introduce what is called symbolic codes. So some symbols were used to replace machine-specific instructions. So instead of dealing with zeros and ones, some mnemonics or symbolic codes were used to represent machine-specific instructions. So these symbolic codes are, we have MOV, move. We have ADD, add. we have SUB, sub, then we have JUMP, jump. What was the move being used for? So for moving items, so if we want to move, maybe if a programmer would want to move an item from one location to the other, the programmer would use the what? The symbolic code MOV, move. If the programmer would want to write instructions to add 2 or 3 numbers, we use what? The symbolic code add. That is for adding figures. If the programmer would want to subtract, then the programmer will use the symbolic code sub for subtracting figures. If we would want to jump from one location or from step 1 to, let's say, step 10 within our code, then we use what? The symbolic code jump to do that. So instead of using zeros and ones, symbolic codes were used to what? To represent machine specific instructions. So example, we have move A, 10, and this instruction means that the computer should move value 10 into a location called register A. So move the value 10 into register A. Register is a location within the CPU that is actually used to store the data that is being processed by the CPU. So what are you saying? That some machine operations are represented using symbolic codes or represented using symbols. But we have earlier on established that computers only understand machine language, and that is zeros and ones. So how does the computer understand this assembly language which uses symbolic codes? So let's look at this. How do you talk to someone who doesn't understand your language? So let's say I speak Twi, the other person also speaks Ewe. So how do we communicate? So let's say John speaks Twi, and then we have Cosmos who also speaks Fafra. And John would want to talk to Cosmos who speaks Fafra, and Cosmos doesn't understand Twi, and John doesn't also understand Fafra. So how can these two individuals talk to themselves? So with this, they will need someone called translator. So the translator will be someone who understands Twi and then also understands Fafra. So that when John speaks his Twi, the translator picks whatever John has said and then convert it or translate it into Fafra for Cosmos to also what? Understand. So the same thing happens here. When they introduce the assembly language which uses the symbolic codes or mnemonics or symbols to represent machine specific operations, they introduce a tool known as the assembler. So the assembler is a tool or a program that converts the assembly language into machine language. So we have the instruction move A, 10. That is assembly language. Then the assembler will come in to convert this assembly language into machine language, that is zeros and ones, so that the computer can actually execute the instruction move A, 10. So we humans are comfortable with the move A, 10, that is symbols, but the computer understands zeros and ones. So the assembler comes between the assembly language and then the machine language to convert it from assembly language to what? To machine language. So though they used symbolic codes to represent machine-specific instruction. Writing instructions using assembly language wasn't easy. So programmers needed something that is quite simple and something that actually resembles the language that they speak. So they gave birth, or they introduced what is called high-level language, HLL. So HLL are designed to be more human readable and resemble our natural language, which makes it easier to understand and also to be able to use. So high-level language use keywords, phrases, and syntax that are just like the human language. So we have examples of them. We have if then, we have for, and then we have while, and these are just few of the many keywords that are used in high-level language. So what are some of the examples of these high-level languages? So we have Python, we have Java, we have JavaScript, we have C++, and then the last one we will talk about is C. So these are examples of high-level languages, or HLL. So how do we convert high-level language to machine language? Unlike assembly language that used assembler to convert to machine language, and the high-level language, we use what is called compiler or interpreter to convert directly to machine language, which is zeros and ones. So in assembly language, we use assembler to convert to machine language. And the high-level language, we use either compiler or interpreter to convert directly to machine language. That is the language of the computer. So let's look at how compiler works. The instructions that we write using high-level languages, those instructions or codes are known as source codes. So the instructions we write using high-level language, those instructions are known as what? Source codes. So compiler takes all these source codes and then converts everything into machine code at once or at a go. So what should have happened is that compiler should have picked the instructions one after the other and then convert each instruction to machine code. But no, the compiler picks all the instructions at once, the source code at once, and then convert everything into machine code at a go. So we have the source code into bracket A plus B bracket close divided by 2. Then compiler takes this source code and then convert everything into machine language. So we say the compiler takes all the source codes and converts everything into machine code at once or at a go. Now let's look at how interpreter also works. Unlike compiler, which picks the source code and then converts everything into machine code at once, interpreter converts source code into machine code line by line. When interpreter picks the source code, interpreter will first of all pick the first line, convert it into machine code, move to the second line, convert it to machine code, move to the third line, and then convert it into machine code. So we say that interpreter converts source code into machine code line by line. So we have the source code, interpreter comes in and then converts the source code into machine code line by line. So we have groups of programming languages. Throughout this lesson, we have mentioned 3 groups of what? Of programming languages. We made mention of machine language, which belongs to a group known as what? Low-level language. Then we have assembly language, which also belongs to a group known as what? Middle-level language. Then we have the last one we made mention, that is high-level language, which also belongs, the name doesn't change, it is still high-level language. So we have 3 groups of programming languages. We have low-level language, we have middle-level language, and then we have high-level language. Before we complete this lesson, let's look at this assignment. What is a machine language? What is used to convert assembly language to machine language? In high-level language, the translators used are do and do. So we want you to mention the translators that are used to convert from high-level language to machine language. Kindly like, comment, and share this lesson for others to also benefit. This is the end of lesson 2. Now, let's look at lesson 3.